Hello, myself Ram. I am here to discuss on the cardiovascular disease. In this section of video, I am going to tell about the basics of heart, and in the next video, I am going to talk about the um, electrical conducting system of our heart. So let's start by the basics. Heart. Heart is a muscular organ located in the thoracic cavity. What is heart? Heart is a hollow muscular organ located in the thoracic cavity. Okay, now I am zooming it out. Okay, it will be understandable. The picture is not good enough, but it is enough to understand. Here it is right atrium, right ventricle, left atrium, left ventricle. Okay, these are the known. These valve are in between right atrium and right ventricle. The valve is known as the tricuspid valve, and in between left atrium and left ventricle, it is known as the bicuspid valve, also known as the mitral valve. Okay, here in between aorta and left ventricle, the valve is known as the aortic valve, and in between right ventricle and pulmonary artery, this is known as the pulmonary valve. Okay, this is superior vena cava, inferior vena cava. These are the pulmonary veins. Okay, so now physiologically, uh, when superior vena cava collects bloods from upper parts of our body and inferior vena cava collects bloods from lower parts of our body, it runs into right atrium. That means the blood which comes to right atrium is deoxygenated. These bloods are coming to right atrium, coming to heart, sorry, for transforming deoxygenated blood into oxygenated blood. Okay, and then after right atrium, it goes to right ventricle and travels to pulmonary artery. Okay, and then to lungs, and in lungs this deoxygenated blood transform into oxygenated and come through pulmonary veins uh, into left atrium, then to left ventricle and to aorta, and aorta supplies to all parts of our body, or we can tell all organs of our body. Here we can say that here we can see that our left ventricle has thicker muscular wall, but our right ventricle doesn't. So why it is so? See, our left ventricle pumps blood to our aorta, and it travels to all organs of our bodies. Okay, from ear to toes. Okay, so it needs to generate really high pumping pressure. It needs to generate high pumping pressure, but right ventricle did not, because it is going to one organ of our body, that is only lungs. Okay, pumping blood to the lungs only, and left ventricle has to pump all around our body. That's why it is thicker and this is thinner. As now structure, as I told, that is 4 chambers we have, 4 valves we have, 4 chambers that I told: right atrium, right ventricle, left atrium, left ventricle. Okay, 4 valves I told, that is 2 atrioventricular plus 2 semilunar valves. Okay, the 2 semilunar valves are the pulmonary valve and aortic valve. 2 atrioventricular valve are the mitral valve and tricuspid. Okay, as I told about the valve, there are presence of valves. So why it is present there? Because when suppose blood comes, one second, when blood comes to left atrium or to right atrium, okay, it will travel to right ventricle. Okay, after traveling to right ventricle, there is a possibility that the blood can go to right atrium. So what the tricuspid valve will do or bicuspid valve will do? They will prevent it, that the blood should not go back. That means back flow should not be there. That's why the valves are present there, and these valves are connected with chordae tendineae. Okay, chord tendineae are there. These valves here in this picture, you can see here clearly. Sorry, Here you can see, I'm zooming it out. These are valve, okay, and this here like this, these are connected with chordae tendineae. Tendons are there, and chordae tendineae are attached with papillary muscles. Okay, for your notes you can write it. Okay, so you can so you understand, I think, that why these valves are present there. That means to prevent flapping back the way into the atria. Okay, now layers of heart. Okay, that is divided into three, that is outer, inner, and middle. Okay, outer is of fibrous silk. Okay, second is of squamous vascular endothelial cells. Okay, and middle is the thick muscular layer. Okay, now come to outer is the tough fibrous, it is made up of tough fibrous tissue. What is the role of it? It stops the heart to over expanding. Okay, and it is made up of pericardium layer that is protective. Okay, now second, it is squamous vascular endothelium cells, made up of squamous vascular endothelial cells. That means it has a smooth blood flow. It allows a smooth blood flow, and it is of endocardium. Okay, known as pericardium layer, endocardium and myocardium. Okay, now from scientifically, myocardium is the middle, endocardium is the inner, and peri means outer. Okay, so middle is the thick muscular layer, bundle of a specialized muscle called cardiac muscle. These myocardiums are known as the cardiac muscle, that is made up of, or you can tell, striated muscle. The structure that separates right side of the heart to the left side of the heart is known as the cardiac septum. Okay, or atrioventricular septum. We can see this is our right side. This is our right side of our heart, and this one is the left side of our heart. So separating this septum is known as the atrioventricular septum, or you can tell it cardiac septum. Okay, now come to the pumping system of our heart. So right side of the heart pumps to the lung. That means it pumps, we can call it lung pump. Okay, and left side of the heart, it is known as the body pump. As we told before that, our aorta supplies all organs of our body, but our right ventricle supply to only the lungs. Okay, now left side of heart, that is the blood is returning from lungs via the pulmonary veins, which is fully oxygenated and going to aorta. Okay, right side of heart as known as the systemic venous circulation via superior and inferior vena cava, going right side of the heart known as right atrium, and go to the lungs. Okay, the important thing we should know that our atria and ventricles are contractile because of the contractile myocardium. Okay, the myocardium, the middle layer of our heart, that is made up of myocardium tissue. As I told here, this is myocardium of smooth muscle, striated muscle. It is made up of striated metal, that is smooth muscle cells. Here you can see striated muscle myocardium. This is smooth, and it has the property of contractile. Okay, so both the atria and ventricles are contractile because of the contractile myocardium. Okay, here one thing you have to know, that both the atria will contract at the same time. Okay, and it will contract at the same time, and the valves like tricuspid and bicuspid will open on down the way and vice versa. Okay, this is normal behavior of our circulation. Now here I have drawn a big circle known as, see what's we have one term known as the regurgitation. Okay, regurgitation is the name of leaking of heart valves, as we studied that we have four valves, semilunar valve and atrioventricular valve, that is aortic valve, pulmonary valve, bicuspid and tricuspid valve. So what is regurgitation? That is means if the valve is leaking, means what is going to happen? There is a backflow, or blood is going back to the left atrium. Okay, what is happening here? If valve is leaking, the blood is going back. This process of leaking, and if valves are leaking, this is known as the regurgitation. Okay, so valves, why do and how to valve opens and closes? How? Because of the pressure changing. Valves opening and closing are due to the pressure changing. And what they do, they provide one-way flow of blood. Okay, you can understand here that is one-way flow of blood means it will flow in one door capacity, not in it will go back, come this. That means no, it will not go back. It is coming from right atrium to left ventricle. It will flow systematically. Okay, when ventricle contracts, okay, as we discussed, ventricles are there in our heart. So when ventricle contracts, okay, when ventricle is contracting, there will be a sound called slump shut. Okay, the mitral and tricuspid valve is closed. Okay, and that noise is called love. Okay, that is known as the first sound, that is sound 1, S1. Okay, or start of the systole. Okay, now if slump shut of the semilunar valve, as we discussed before, semilunar valve are the aortic valve and pulmonary valve. If the slump shut of semilunar valve is happening, then the noise is called dub, and that sound is known as S2. Okay, love dub is the normal heart sound. Love is known as the S1 sound first sound of our heart, and dub is the second sound of our heart. See here I am zooming it out, you can write the notes. At the start of the systole, okay, at the start of the systole there will be, we will heard first heart sound. Okay, and marking the end of the systole we will hear the second heart sound. Okay, the end of the systole we can hear the second heart sound. This is our first video. In the next video we will continue internal electrical conducting system of our heart. So thank you. This was my first video on YouTube. If you like, please subscribe. Thank you so much.